Hello and welcome. In this video, we are going to talk about the identity and inverse matrices. And as you're seeing in your screen, you have been given a matrix A and you have been asked to find the inverse. So I'm going to take us through the steps that you're going to follow in finding the inverse of a 3 by 3 matrix. So the order of this matrix here is a 3 by 3 matrix because it is having 3 rows and 2 and 3 columns. Yeah. So the first step, you're going to find the determinant of this matrix. And this determinant of this matrix we're going to find by using the minor matrices. So we'll be taking the value at row 1, column 1, that is 1, of which it is going to be a positive because of this rule that we're using. So you're going to add the row plus the column. So this value here is in row 1, column 1. So you're going to have negative 1 raised power 1 plus 1. This one is giving us negative 1 squared, which is a positive. So that is why we're having a positive here. Then the minor matrix here will be now the values that are not on row 1 and not on column 1. So there are these values here. So we'll be having 0, 1, negative 1, 0. Then we're still going to use this rule here on this value. So this one is on row 1, column 2. So that is 1 plus 2, which will be giving us a negative. So we'll be having negative 2. The minor matrix are the values that are not on row 1 and are not on column 2. So that one will be negative 2, 1, 1, 0. Then the next value is negative 1. So this value here is on row 1, column 3. So it is 1 plus 3, which is going to give us a positive. So we'll be having positive, but the value itself is a negative. So the minor matrix will be now negative 2, 0, 1, negative 1. Yeah. So you are going to still find the determinant of these minor matrices. So we'll be having 1 into the leading diagonal is 0. We are taking away, so it is 0 minus 1. So because 0 times 0 is 0, minus 1 times negative 1 is negative 1, minus 2 into negative 2 by 0, 0, minus 1, plus minus negative 2 by negative 1, that is positive 2, we're taking away 0, and this one is going to give us 1. Then this is negative 1 inside this bracket multiplied by negative 2 is going to give us a positive 2. Then we are subtracting 2, and this one is going to give us 1. So our determinant is 1. And for us to find out the inverse, we are going to be having, so A inverse will be having 1 over the determinant multiplied by the adjoint matrix. And the adjoint matrix, we are going to find it in a very easy way. And this one is going to be now, we are using the cofactor matrix method, cofactor. So we are going to get a cofactor matrix here, of which is going to be made up of minor matrices from this initial matrix. So we are going to stand on row 1, column 1. And we are going to have the minor matrix on that row. That one will be 0, 1, negative 1, 0. So if we stand on this point here, we're going to use the values that are not on row 1 and they are not on row and on column 1, sorry. Then we'll be having the second value here. So the minor matrix there will be now negative 2, 1, and 1, 0. And thirdly, we're having negative 2, 0, and 1, negative 1. Yeah, so that is now the cofactor matrix. The values of the cofactor matrix will be those one in row 1. So we are moving to row 2. we are standing on this value negative 2. So we'll be having hiding this value here and the value in the middle. So we'll be having the cofactor matrix now will be 2, negative 1, negative 1, 0. Okay, the third value will be standing on this 0 here. Then the minor matrix now will be 1, 1. This one will be negative 1, 0. And lastly, thirdly on this row, we're going to have 1, 1, 2, negative 1. So in our last row, we're going to have, we are standing on this value 1 here. So we'll be having the values that are not on row 3 and they are not on column 1. So we'll be having 2, negative 1, and 0, 1. The next value there will be now having the values that are not on column 2 and not on row 3. Those one will be 1, negative 2, negative 1, 1. Then lastly there, the values that are not on row 3 and they are not on column 3. We'll be having 1, 2, negative 2, 0. Yeah, it is important to note that on this point you have to be keen in how you are going to select these values, because if you mess up here, you are never going to get the answer. Yeah. So we're also going to still use this rule to find the values, the operation signs that are going to be here. And when you use the same values, you are going to have this one to be a positive, negative, positive, negative, positive, negative, positive, negative, positive. Yeah. So this one will be giving us a cofactor matrix, whereby we are going to find the determinant of these matrices. So we're having 0 minus, we're going to be having, this one is 0. Okay, this one is 0 minus 1. So it is 0 minus minus 1. That one is going to give us a positive 1. I hope we are together there, because it is 0 minus, which is already there, again minus 1. Then in this second value here, we're going to have negative 2 times 0 is 0 minus 1. We're going to get a negative 1. But we have another negative here. It will also be giving us a positive 1. Also, on the third value here, we're going to have negative 2 multiplied by negative 1, giving us positive 2. When you are subtracting 0, that one will be 2. Yeah. Then we are moving to this point. 2 multiplied by 0 is 0. Then we are subtracting 1. So 0 minus 1 is a negative 1, but we are having another negative here. That one will be giving us now a positive 1. I'll continue. 1 multiplied by 0 is 0, minus minus 1, positive 1. Yeah, hope you are following. Then on this value here, we're having 1 multiplied by negative 1. That one is giving us negative 1. Again, we are subtracting 2. We are going to get negative 3. But there is a negative sign here, so it is negative 3 times negative 1. That one will be positive 3. And lastly, on the third row, we are having 2 multiplied by 1. That is 2 minus 0, 2. Then again, 1 multiplied by 1, 1. Then we are subtracting 2. We are going to get negative 1. So it is 1 minus 2, negative 1. But we have another negative here. That one will be giving us a positive 1. And on the now third row, third column, we are going to have 0 minus minus 4. That one will be giving us positive 4, because 0, 2 by negative 2 is negative 4. And the negative, so we're having 0 minus minus 4, giving us a positive 4. So this one is the cofactor matrix. But for us to find the adjoint, you are going to transpose this matrix here. And for us to transpose, we are going to change the rows into columns. That is now what we mean by transposing. So it is now becoming, now the column, they are going to become the rows. So we'll be having negative 1, 1, 2. Then again we're having 1, 1, 1. Then 2, 3, 4. Yeah, so this is the adjoint. But now for us to find the inverse, we are going to have 1 over the determinant, and the determinant was already 1, so it is 1 over 1, basically having no impact on the matrix, into 1, 1, 2, 1, 1, 1. So this is now the inverse, 1 over the determinant multiplied by the adjoint, and this one will still give us 1. So this is the inverse of that matrix, and for us to prove that we have the correct value of the inverse, we are going to multiply the matrix by its inverse, and we are going to get the identity matrix as the answer for you to prove that you are correct. So you are going to prove that the value you have gotten, the matrix that we are having here, is an inverse by multiplying it by the original matrix. So we'll be having, this is 1, 2, negative 1, which was the original matrix, negative 2, 0, 1, 1, negative 1, 0, and you are going to multiply it by the inverse, 1, 1, 2. So we know we multiply matrices. We're having row multiplied by the column. So it is 2 multiplied by 1, that is 1, added to 2 multiplied by, that is 1 by 1, 1, then 2 by 1, that one is 2. So 1 plus 2 is 3, and again negative 1 by 2 is negative 2. So it is 3 minus 2, that one giving us 1 on the first row, first column. Then we are moving to this now, the same row multiplied by the column 2. So it is 1 by 1 plus 2 by 1, that is 3. Then again negative 1 by 3 is negative 3. So it is 3 minus 3, giving us 0. And moving to this last column here, we are having 1 by 2, 2 plus 2, that is 4, again minus 4, 0. Then we're moving to this second row here. So it is negative 2 by 1, negative 2, 0, 2. So it is negative 2 plus 2, giving us a 0. We are moving to the second column. Negative 2 by positive 1, it is negative 2. Then 0 by 1 is 0. Then 1 by 3 is 3. So negative 2 plus 3 is positive 1. Negative 2 by 2 is negative 4. 0 by 1 is 0. And 1 by 4 is 4. So negative 4 plus 4, giving us 0. Then 1. Now we are moving to row 3. So it is 1 by 1, 1 by negative 1. So it is 1 minus 1, giving us 0. And 0 times 2 is 0. So that one is giving us a total of 0. Then we are moving to column 2. It is 1 by 1, 1. 1 by negative 1. It is negative 1, so it is 1 minus 1, 0, and 0 by 3 is 0, giving us a sum total of 0 there. And lastly, 1 by multiplied by 2, 2 minus 1, that is giving us 1, and 0 by 4 is 0, so this one is giving us 1. So you can see that we're having the identity matrix of a 3 by 3 matrix, meaning that the value that we obtain as the inverse here is correct. And when we are talking about the identity matrix, is a matrix that is in this form, that has no effect. When you multiply by any matrix, this matrix has no effect on any 3 by 3 matrix. It remains the same. So this is what we call an identity matrix. Thank you for watching. Stay tuned.